In this demo, I'll compare the specific heats of these two different metals, brass and aluminum. I then will evaluate which one has a higher specific heat and which one has a lower specific heat. In order to do this experiment, I will need one pot filled with boiling water, 2 cups with the same amount of water and same initial temperature, 2 different metals that contain the same mass, that will be the brass and aluminum, and finally, a water thermometer. In this demo, I will put each metal in boiling water for 1 minute. In that 1 minute, the 2 metals will gain more heat from the boiling water. In order to find out which metal has a lower specific heat, you would have to see which metal obtains more heat in the boiling water process. This is because the metal with the lower specific heat does not need as much energy to heat up that metal. But since it's very inaccurate to just put a thermometer on the metal and measure the temperature that way, I'm going to put that metal in a cup filled with water. That way, we can see which metal releases more energy, thus being a lower specific heat. But both the waters have to stay in the water for an equal amount of time, or else it would be unfair. So both of the metals are going to be in the water for 1 minute. After 1 minute, I will measure the final temperatures of the water. Whichever metal gave the highest temperature difference meant that that metal had the lowest specific heat, because it released the most amount of energy in the water. Warning, do not try this at home without parental supervision. Let's start the clock.
2, 1.
Let's start the clock.
2, 1.
After doing this demo, the brass changed the water temperature from 95 degrees Fahrenheit to 102 degrees Fahrenheit. The aluminum, however, changed it from 95 degrees Fahrenheit to 99 degrees Fahrenheit. Seeing how the brass increased its water temperature more than the aluminum did shows that the brass obtained more heat during the boiling water process. This means that it took less energy to heat up the brass than it did to heat up the aluminum. So after this demo, I can prove that brass has a lower specific heat than aluminum does. But now that I've done my lab, I want you to do your own labs. Here's your assignment. I forgot to cool my water bottle and it's a very hot day and I want to cool my water bottle. I want to figure out which method is the most efficient method to cool a room temperature water bottle. Surrounding the water bottle with ice packs for 5 minutes, or putting the water bottle in the freezer for 5 minutes. Now in order to do this experiment, you need 2 identical water bottles with the same mass and same volume, both at the same temperature, preferably at room temperature. You need 1 thermometer, 2 ice packs, and a freezer. What you will do is that you will put 1 water bottle in the freezer, while you will wrap the other water bottle with ice packs. You will leave it in the freezer for 5 minutes. You also will surround the ice pack for only 5 minutes. After 5 minutes, you will open the water bottle and put a thermometer in it and see which one is actually colder. Please start your lab. My results prove that putting it in the freezer for 5 minutes was a more efficient way to cool a room temperature water bottle than wrapping it around cold ice packs. This might be because when I put the water bottle in the freezer, it was in an atmosphere where it was completely 0 degrees. But while I surrounded the other water bottle with ice packs, it was not in a complete environment where it was totally 0 degrees. What I mean by that is that the water bottle was also exposed to areas where it was also to room temperature. In some ways, there is a possibility that while the water bottle was transferring energy from the ice pack to the water bottle, there is also a possibility that the water bottle is also transferring energy from the water bottle to the atmosphere. This would make it not as cold. But I hope you like this interactive thermodynamics video, and since it's getting late, we got a break here.